I think next we will move on to randomizing or pseudo-randomizing the colors of the blocks within the quad. So, which formation of silvers and oranges we'll use for a specific spawn. That'll be pretty simple. And then after that we can go ahead and move on to the matching logic, and that'll be probably pretty fun, so that'll be cool. But before we do that, I'm going to clean up some of the things that I just added. This move down type, I don't think we'll need this, so I'm going to go ahead and delete it from the project entirely. And I need to delete the move down one space function. So I'm just going to check to make sure I'm not calling it anywhere. I don't think I'm calling it anywhere. So this is just showing the function itself, so it only exists in its own definition. So I can just delete it, I think. Whereas if I, find the references for move left half, there shall be the two places where I'm calling it here in the main event graph. So that's just to show this isn't being called anywhere, so I can go ahead and delete it. And compile, and the game should still run as before with the splitting occurring, and we're still good. So now we can add the randomization of the spawn colors. So we can probably do that in game mode where we spawn in the new quad. When we expose the colors here, probably have to refactor something here, because we want to have one easy access point for customizing which color possibilities there are. So probably when we spawn in a new quad, before we actually spawn the actors, we can decide which colors each one will be, and then set them when we actually spawn them. So what we can do here is, before we even do this sequence, we can scoot that over, and I'll probably make a new function here called pick colors or something like that. It's not good at all. Decide colors for new quad. That's not much better than the old name that I just said, but so here we're just going to have like a random integer. This will definitely need to be tweaked for like game balance purposes, but for now I'm just going to have a random integer between 0 and the number of types that we decide there will be here. So num configurations, or that's that's not a very good name for it, but what I mean by that is the number of possible color and rotation variations for the quad colors. So like if you think of this 2x2 square, that can only be where each of the two blocks can only be one of two colors. Then you have a couple different shapes, like you have an L like we have right now, where there's like 3 of one color and 1 of the other. And you could have like 2 parallel lines, or you could have where the silver is diagonally, there's neither of them are adjacent, they're like diagonally connected. Or you could have a solid where there's all the 4 of the same color. And that should probably be pretty rare, because that's a powerful block in Lumines, because you can use that to connect a lot of blocks at once. So there's the L shape, there's parallel lines, there's diagonal, there's a solid block, and I believe that's it. Then there's only, all the various rotations, like the L could start like that, the L could start like that, or like that, or like that. Or it could be flipped where it's 3 silvers and 1 orange instead of 3 oranges and 1 silver. So there's many ways to implement all these various combinations, but I think I'll just brute force it kind of for now, unless as I'm doing that I can come up with a better way to do it. But so I'm just going to do switch on int here. So based on what this random value is, we'll do one of the configurations. I don't know what this number is going to be yet. I'm just going to put 8 for now, but it's definitely going to be different than 8. But I'll just add a couple for now, and we'll come up with more as we go. So let's start with the solid colors, because those are going to be like special, probably. Extra rare, which we can do by, there's many ways that we could change the rarity of these, but we could have like every other one be connected to 2 numbers, and then have the solid be connected to only 1 number. That way they're only half as likely as the rest to be picked. But you could also do, I don't know, any other ways of picking, weighing the rarities of the different the likelihoods. So for now, let's just say, okay, so the form this will take, I think, is an array. So we're going to have 2 levels deep here. So if you follow me for a moment, I'm going to have an array of booleans. And colors array is what I'm going to call it. And it's just going to be an array of 4 booleans. And these will decide what the spawns are going to be for the bottom left, top left, bottom right, and top right, respectively. So index 0 of this array is going to decide the color for this block. Index 1 will decide this block. Index 2 will decide this block, and index 3 will decide that block. I mean, it's pretty arbitrary which one is which, but that's just for the purpose of, having something. It's got to be mapped somehow, so that's how I'm going to do it. And this new function that we've made called decide colors for new quad is going to have a output value of the array of booleans. And it'll be an array, so left click and choose array, and the outputs of this is just going to go to the 4 pins here for the spawn parameters. I can go ahead and wire that up now, but it's not going to do anything until I populate the function, the inner function. Now, I think to avoid having nasty red lines coming through everything, I'm going to do a local variable here. So it's a local variable, but it's a separate local variable from the variable contained in this function, but it's going to hold the same data. So I'm going to give it the same name, if that makes sense. I hope it does. So the only reason I'm making this local variable is for visual clarity, so that we don't have the red lines weaving out throughout these white lines and going around that. It's just going to be more mess than it needs to be. And I hope the performance isn't impacted significantly. I don't think it would be from just one array of booleans. So we're going to set our local variable within this inner function to some selection of booleans, and then at the end just output that array. So it's going to be like a big web all connected into one output node, because it's going to be the same node that just outputs the local array. And we're going to have a bunch of make array nodes that are each 4 pins. Maybe I can do this. Okay, perfect. Then I don't have to have extra nodes that just connect in that are just literally 1s and 0s. So now we just have checkboxes inside this one node. That's acceptable, I guess. So we're going to have a bunch of these. Still going to look a bit messy, but we'll do the best we can to organize it. And this is where the comment, the node specific comments that I was talking about earlier, where you can click this like ... You can also right click the node and type the comment here, but you can also left click. It does the same thing. If you left click this, the ... right there, then you can type in, like, let's say solid color 0, which is a square where the whole quad is all the same color. And this is the array that makes that result. And this is just the English description of what that array represents for ease of reference. Now we're going to be duplicating this whole thing, I guess. I'm just going to have a bunch of these, so get ready for that. And then this one will be solid color 1. I'm not going to duplicate the dots every time, but maybe I will. Solid color 1, and this is going to be all checks. So that'll be a solid orange or silver, whichever color is 1. Yeah, I don't even know which one's which anymore. And now we'll do the parallel lines. Just arbitrarily, I'll choose to do that. So there are 4 total ways that the parallel lines could manifest. So it could be, vertical parallel lines of orange, and on the orange on the left, silver on the right, or flip that around, or turn them horizontally. So I'll call this parallel vertical lines color 0 on the left. And I'll call this one parallel vertical line. I think you can tell where this is going to go, so this is going to be several minutes of just setting up these Boolean configurations, so you can go ahead and skip this if this is not enriching to you, but you're welcome to continue along with me, or you can, I'll try to show you at the end what I ended up with, so you can just skip to the end and look at that and make your own, because this is going to be a bit of a painstaking replication of this format over and over again. So color 1 on the left this time. Just wire up all these nodes here, the wires. And then we have parallel horizontal lines with color 0 on top, and then parallel horizontal lines color 1 on top. I'm going to stay consistent here and not put a space between color and the number. And I'm treating them all with equal rarity, so that's maybe imbalanced, but we'll see how it works at the end. So to accomplish parallel lines with color 0 on the left, I'm going to make a visual reference. I just need to take note of the order in which these array elements are going to correspond to which of the quad elements. So it's bottom left, bottom right, top right. Bottom left, top left, bottom right, top right. It'd be better to be more consistent in my ordering throughout the entire project, but at this point I'm not going to go back and reorganize everything about that. It's inconsequential at the end. It just matters for the purpose of writing it. So this corresponds to this, this corresponds to this. But this isn't actually doing anything. I just put them there so I can look at it as I go through deciding which of these are true and which are false. Hopefully that makes sense what I'm doing there. So if I want parallel vertical lines with color 0 on the left, that means I need these ones to be color 0 because they're the left-hand ones, and these ones to be color 1, so turn those two to true, index 2 and 3. And now we want parallel vertical lines with color 1 on the left, so just the opposite of that. So, like so. And now we want parallel horizontal lines with color 0 on top, which means the ones that are the tops will be 0, so bottom and bottom will be true, so that 0 is on top, and then just the opposite of that for the next one. And now we'll do the L shapes. This is really going to get sprawling. It's going to get so bad you can't look at it all on one screen, which is fine. Your blueprints don't all have to be super concise and tiny. So let's move this down so we can think about the L shape. I guess I'll do L shape with 1, 0 first. So if we want color 0 at the top left, then that's going to be top left here. So like so. L shape with color 0 at top right corner. Again, it's just arbitrary which ones I'm doing in which order. Top right to be 0 and the rest to be 1s. This is riveting stuff, folks. One cool thing is now we can, once we do this one, we can easily do the next 4, by just clicking all the checkboxes. That'll be super fun. Let me just do a quick sanity check here. We got second one, fourth one, first one, third one. Okay. So now all we need to do to invert that is just literally invert every checkbox. There's no invert function, which is fine. And just change these 4 comments to say 1 instead of 0. Oops, it's always a riot. What I'm going to do later is add in all of the reroute nodes one by one so I can sort of align them in a way that minimizes overlaps. But they're going to fan out a little bit. I'll show you what I mean if I survive that long. So we've done the 8 variations for the L. We've done the 4 variations for the parallel lines. We've done the 2 variations for solid colors. There are going to be 4 variations of the diagonal, I think, or is there only going to be 2 variations? Yeah, there's only going to be 2 variations for a diagonal in terms of visually distinct, because, that's only 2 visually distinct variations of that particular configuration. But for balance purposes, you probably want to make that more common because that's a little bit of a trickier block to use. So I'm still just going to do 1 of every distinct variation though. So after those 2 we have, is that it? I think that's it. Because parallel and the diagonals are the only possible ways to have 2 of each type, so I think that's it. Yeah, so it might only be 16 total possibilities. So if we want the alternating colors with color 0 at top left, and call it alternating colors with color 1 at top left. So that means TL is true, or no, if we're doing this one first, TL is false and BR is false, and the other 2 are true. And that creates the checkerboard pattern, diagonal pattern. And this will be the opposite, where these 2 are true. So the top left is color 1 and bottom right is color 1. And the other ones are color 0. Now again, this is like a case where you could just, live with the fact that there's the nasty amount of white lines all over the place, because it's not really important that they're overlapping. It's not really obscuring any complex logic. So it would be fine to leave it like that. In fact, you might think it looks better that way than the way I'm going to do it. But I just want to sort of center all of these, like kind of like that. And then when I put the dots in, the farther down ones are going to have to be further out or closer. I'm not sure which, but it's going to have to kind of have a diagonal line. If you were to connect to all these reroute nodes, the line will be diagonal, otherwise they'll be still overlapping. If they're just straight vertically like this, the lines are still going to overlap. So to reduce that, you kind of have a diagonal line coming in, but that's a lot of extra time for what at the end of the day has literally no function. So that's something that it's probably a waste of time to do it like this, but it saves my sanity sometimes. Also, I need to move this down so that it's centered too, otherwise it's never going to work. And now it's kind of working, actually. It's looks like an onion or something on its side. Delete those, we don't need them anymore. I haven't even tested that this works at all yet, so that was a lot of time spent if it doesn't even work. So let's hope it works. So now at spawn new quad, one of those 16 combinations is going to come out here in an array. And we've set the array, the local variable array, so that we can just pull the indices from here. Since it's a, Boolean value, it doesn't matter whether it's a copy or a reference. We're not going to change it anyway, so it doesn't matter. We're just going to hard code the indices here, 0, 1, 2, 3. And one more time, the reason why I made a local array here is just so I don't have extra red lines coming out here. It's not like it would make it that much uglier. I just wanted to do that, but either way is fine. So now we have that, and now we're just going to see if it even works at all. There we've got the parallel lines vertical, L-shape, with top left, solid. Okay, and it seems to be working. Let's see if we get a diagonal eventually. There's only a 1 in 8 chance that it's a diagonal. We should get one. I'm just not getting one right now. Oh, you know why? It's because I set that value to 8, and so we're only getting the first 8 options. So I need to go to the game mode again and go back to decide colors. And since there are 16 total options now, we know that we set this to 16. And now we'll get diagonals occasionally. There we go. Perfect. This is going to be very fun once it actually works as a game. But yeah, Luminous is a great puzzle game. If you've never played it, it's very easy to enter a zen-like state of just matching blocks for hours. A large part of what makes it so engrossing, I think, is the real game's music and sound effects and particle effects and everything they do to add a bunch of, sugar to the experience. But the solid puzzle mechanics are definitely what elevates it to a truly great experience, I think. Anyway, we need to get to the most important part of making the puzzle game logic work, which is actually matching the blocks and deleting the blocks when they are matches. And there's a part we haven't even started talking about yet, which is the what is going to happen. It's going to break when I try to spawn in a block on top of itself. I wonder what's going to happen. It's going to be interesting. We need to set that as a game over state, but for now it's just going to spawn a block on top of itself and maybe crash. So yeah, this is not good behavior, what's happening right now, obviously. But they're just spawning on top of each other. No errors, but it's just going to continuously spawn a bunch of blocks on top of itself and probably eventually crash, which we don't want, obviously. We'll need to add a game over state. That'll probably be one of the final things we add, though, because for now we need plenty of other things to focus on.